This video is going to review over kinetic energy problems and potential energy problems. Remember that your kinetic energy formula is 1/2 your mass multiplied by your velocity squared. Potential energy is your mass times your gravity times your height. And we know that gravity is a given of 9.8 meters per second squared, because that is what gravity is on Earth, unless we're talking about another planet. But always use 9.8 unless otherwise noted. So our first problem, I'm going to read you the problem. You're going to then pause the video, do the problem, and then play the problem to see the answer to check your work. So our first problem we're going to do, determine the kinetic energy of a 625 kilogram roller coaster car that is moving with a speed of 18.3 meters per second. Pause the video, do the problem, and then play when you're ready to check your work. So looking at this problem, it says determine the kinetic energy. So we are looking for kinetic energy, so we know that we are going to use KE equals 1/2 mass times velocity squared. So look at the information that they provide in the problem. We have 625 kilograms. That is our mass, M. And then we have speed, which is 18.3 meters per second. So that is our V. So we plug in this information, 1/2 of the mass, which is 625 kilograms, multiplied by our speed, which is 18.3 meters per second, and that's squared. Now we just figure out the math. Half of 625 is 312.5 kilograms, and we multiply that by 18.3 squared, which is 334.89. And you take our two numbers we found there and multiply them together, and you get the answer of 104,653.125 joules. And since we're looking for energy, our label unit is going to be joules. So no matter if it's kinetic energy or potential energy, it will be the label unit of joules. Problem 2. Missy Dyewater, the former platform diver for the Ringling Brothers Circus, had a kinetic energy of 12,000 joules just prior to hitting the bucket of water. If Missy's mass is 40 kilograms, then what is her speed? Pause the video, solve your problem. So here it's asking us, what is her speed? So we look at the two equations, and the equation with the speed variable in it is the kinetic energy. So kinetic energy is 1/2 your mass multiplied by V squared. So the information they provide us is kinetic energy. That's a giveaway of what equation to use also, is 1200 joules. So 1200 joules, or 1000 joules, equals 1/2 of the mass. And the mass is 40 kilograms multiplied by V squared. So half of 40 is 20, so we get 20 kilograms. Multiply that by your V squared, and you have your 12,000 joules over here. To get V by itself, we need to do the opposite of multiply is divide by 20 kilograms. That cancels these two out. Divide by 20 over here, and you get an answer of 600 equals our V squared. Now this is not just speed, this is speed squared, so we need to get rid of our square. So we take the square root on each side to get rid of our square, and the square root of 600 is 24.5 meters per second. So that is our speed. Problem 3. A cart is loaded with a brick and pulled at a constant speed along an inclined plane to the height of a seat top. If the mass of the loaded cart is 3 kilograms and the height of the seat top is 0.45 meters, then what is the potential energy of the loaded cart at the height of the seat top? So here, pause the video, do the problem. Okay, so what is the potential energy? So here it tells us we're going to use PE equals mgh. So we look in the problem and it gives us 3 kilograms is our mass, 0.45 meters is our height, and again gravity is our given, so we know that that is 9.8. So we fill in our information and we have 3 kilograms multiplied by 9.8, because that's what gravity is, meters per second squared, multiplied by our height, which is 0.45 meters. So you plug that in a calculator and you get the answer of 13.23 joules. A 4-kilogram rock is rolling 10 meters per second. Find its kinetic energy. Pause the video, complete your problem. So it's asking for kinetic energy, so you automatically know it's Ke equals 1/2 mass times velocity squared. So we plug in 4 kilograms for our mass, 1/2 of 4 kilograms multiplied by our speed, which is 10 meters per second. And you have to remember to square it. That is a common mistake. So 1/2 of 4 is 2 kilograms. And then 10 squared is 10 times 10, so we get 100 meters per second squared. And so 2 times 100 gives you the answer of 200, and this is kinetic energy, so it is joules. Next problem. A 8-kilogram cat is running 4 meters per second. How much kinetic energy does it have? Pause the video, complete your problem. So again, here it tells you what is the kinetic energy. So Ke equals 1/2 mass times velocity squared. Plug in our mass that's given and our speed that's given. So 1/2 of 8 kilograms multiplied by 4 meters per second squared. So 1/2 of 8 is 4 kilograms multiplied by 4 squared, which is 16 meters per second squared. So plug that into your calculator, and 4 times 16 gives you 64 joules. Calculate the potential energy of a 5-kilogram object sitting on a 3-meter ledge. Pause the video, complete your problem. So this is asking for potential energy. So now we are using PE equals mgh. So here it gives us our mass, and here 3 meters gives us our h. So it'll be 5 kilograms multiplied by gravity, which is given 9.8 meters per second squared, multiplied by the height, which is 3 meters. Plug that into your calculator and you should get the answer of 147 joules. Next problem. What distance is a book from the floor if the book contains 196 joules of potential energy and has a mass of 5 kilograms? Pause the video and complete your problem. Okay. So here it gives you potential energy, it gives you mass, and it says what distance is the book from the floor. So this is h, and this is what we're looking for. So since it tells us potential energy, we know that potential energy is the equation we're going to use. So we plug in 196 joules for our potential energy, our mass of 5 kilograms, our gravity of 9.8 because that's what's given, meters per second squared, and then our variable of h because this is what we're looking for. So we go in and plug in 5 times 9.8 and we get 49 as our answer, multiplied by h still. And we have 196 joules over here. To get h by itself, we do the opposite of multiply and we divide. So 49s cancel out, and 196 divided by 49 gives you 4, and this is our height. so we are labeling this with meters. An automobile is sitting on a hill which is 20 meters higher than the ground level. Find the mass of the automobile if it contains 362,600 joules of potential energy. Pause the video, complete your problem. So it says find the mass. So mass is what we're looking for. So we look at each equation, both has mass in it, but it gives us the height and it gives us the potential energy. So we know that we are using PE equals mgh to solve this problem. So we are looking for mass. So our potential energy is 362,600 joules. M is what we're looking for. Gravity is given, so we know it's 9.8 meters per second squared. And our height is 20 meters. So we plug this in and we do 9.8 times 20 gives you 196. And we have our energy over here. And to get M by itself, you do the opposite of multiply and divide to cancel out your 196. And then 362,600 joules divided by 196 gives you the result of 1,850. And this is mass, so we are going to measure this in kilograms. Last problem. How fast is a ball rolling if it contains 98 joules of kinetic energy and has a mass of 4 kilograms? Pause the video and complete your problem. It says how fast is a ball rolling? So this is what it's asking you. So we are looking for speed. And it gives you kinetic energy and it gives you mass. So we use kinetic energy as 1/2 mass multiplied by v squared. So it gives us kinetic energy of 98 joules and half of the mass, which is 4 kilograms, multiplied by v squared. And v is what we're looking for. So half of 4 is 2 kilograms multiplied by v squared. We have our energy over here. To get v by itself, we do the opposite of multiplying. We divide by 2 kilograms. So those two cancel out, and 98 divided by 2 kilograms gives you the answer of 49. And that equals v squared. But we don't stop there because we need to get rid of the square. So we take the square root on each side, and the square root of 49 is 7, and we're looking for speed, so it's meters per second is our label unit. So this covers potential and kinetic energy. If you need help with your work problems, look at the work video that is to follow.